Hello everyone. In this video I want to talk about four different topics that are related to datums mostly, and partial datum feature, datum target, common datum feature, and then another one which is similar to one of them. It's not about datum, but it's called continuous feature, right, which is kind of similar to this common datum feature. So I want you to know the symbols for them, so when you see those symbols in GD&T, you understand what it is that the person is talking about. So the first one is partial datum feature. So sometimes when you want to use a datum for a part, you might not need to have the entire datum. I mean, if you look at this part here and how this small part is attached to the bottom part, you see that only this portion of it, right? Only this part of it is really assembled. So you might just use that part for a datum and not the entire bottom surface. So when you're referring to the bottom surface as A here, you say, hey, A is not the entire surface. You use these dash lines, and then you provide a basic dimension of 4D and say, hey, only the 4D, the size of 4D of that, and what? The entire surface on that length of 4D. So basically whatever here I'm shading with red, this is datum A, okay? Not the holes, but everything else. This is datum A, okay? So that's called the partial datum feature. Another example is here, again, if you look at this part that has a shoulder and only a portion of this shaft is mounted inside the bearing, you can see that I don't need to have the entire cylindrical surface for a datum here, right? And here I'm just referring to only the first 30 mil of the shaft, which is in contact with the bearing, and use that as datum A. Okay, so that is called a partial datum feature. So whenever you see this dash line and a dimension in addition to a datum symbol, that means a partial datum, right? So in SolidWorks, let's say you have something like that, and you want to, let's say, use this datum bottom surface as datum A, but only a portion of it. So first we need that dash dotted line for a portion of this. We need to insert that, give it some dimension, and then add this datum symbol, right? So in order to insert the dash dotted line, we might go to the drawing, to the sketch, I'm sorry, and see if we can add a dash dotted line here. So I can use a line, right? I can use a line and insert a line here like that, okay? And I can even force this point and this edge here and that point to be basically coincident, if it allows me to do it, because sometimes it doesn't, right? So you see it's already coincident, so let me bring it down. And the thing is, I want this dash dotted line, okay? And if I say for construction, you see, so it becomes like a dash dotted line here. And now what I can do is give it some dimension. So say here, I want this guy to be, let's say, the first 30 mils, okay? And then this 30 mil has to be a basic dimension like this, right? And then what I need to use now, my datum symbol, right? And as you can see here, the datum symbol should, with a leader, refer to what? Refer to the dash dotted line. So in this case, we need to put it on this one like that, okay? And you might call it whatever you want. You might call it A or B or whatever. Let's say it's the first one, so we call it A. And if you want, you should be able to convert it to a leader too. This one does not have a leader, it just has the stem. Let's see if I do it this way. Okay, here. Look, and let's bring this point like that. Okay, I should be able to, as you can see, I should be able to put it on a leader like this. Look. Okay, so this is how you do it in SolidWorks. So now I know A is only referring to the first 30 mil of the bottom surface, not the entire thing. The next topic that is related kind of to this previous one is called the datum target. Okay, so here again, you're referring to a part of a surface and sometimes even a single point, not a part of a surface, just a point, as a datum to save money or time. And what you can do, especially if it's a point like or a small circular surface of the surface. So what the difference between this case and previous one is, one, it could be a point. Second, it might not be a point, but it might be like a small circle, but the shape of the circle is different from the shape of the surface. In previous case, you see the shape is no different from the surface itself. It's just a portion of it, right? It's just a portion of it, but it is using the boundaries of that bottom surface. In this bottom case here, it's not using these boundaries. It's just that small circle, okay? Or as I said, it could be a point. So that's the difference between a partial datum and a datum target. So how would you show a datum target? Well, for a datum target, you use this symbol. Okay, it's like a circle divided in half and it's attached to the point. And if it's a point, you have to add a cross to that location. You have to use basic dimensions to exactly tell where that point is. And you give it a name like point P1 or something, if it's a point. If it's a surface, then you have to draw what? You have to draw a dashed circle for that. And then you have to provide the location of that with basic dimensions, location of center of it. And also, instead of calling it P, you call it A because it's an area. And the size of it, you have to provide on the top portion of the circle, say phi of 6. Okay, so this is how you do a small patch, because those small patches are the only things that are in contact with the object lens. And the goal here is to save money and time, because when you have a bigger surface, to qualify that, to measure that, and to measure everything with respect to it means more time, and more time means more money. So here we might use smaller size areas or points as our datum, and we call it the datum target. Okay, so let's see how we do it in SolidWorks here. So let's say, for example, I have a point here and I want to use that point as a datum for myself on this top surface. So as I said, the first thing is you need to add an X, right? You need to add an X or a point. So you go here and you add a point. And then here I added dimensions, right? So I used the dimension tool like last time and then provided the offset of this point with respect to these two edges, made them basic. And now you use the datum target, okay? Under annotations, you click on the datum target and here we go. So you put it there. And you see when you do it, it adds the X for you as well. And now you can go back here and now you have names that you need to provide, and this point is P1, and that's all we need to do. Okay, so here we go. This is our datum target P1. Now if it's a circle that you need to provide, then you have to draw the circle. So again, let's go to sketch and draw a circle here like this, for example. And let's see, we give it a diameter of 10 maybe. And then we need to exactly position it where we want. So let's say we have this distance, right? And then we have basically this one. Provide that dimension as well. There we go. So here is my circle that I'm going to be using, and I don't need that dimension of 10 here. I just wanted to determine that, so I'm going to put it in the datum targets. Okay, so 40 and 40, and now the question is, can I get this guy to be hatched, right? Just like these. Is there a way to hatch it like that? And so here, if we go under annotation and we use this area hatch or fill command, you see here I can have it hatched with an angle and the space, right? So here, something like this. So it's hatched now, and now we go to a datum target and put it right at the center of this shape here, bring it out, and then go down to the information. So it is called A1. Let's go back here. It is called A1, and the diameter, as you see, similar to those, we have to say phi of 6. So let's see if it allows me to do a phi. And by the way, you see here, it has that symbol too. So if you want, you can use these guys. So you can just click on that, right? You see here, it adds that for you if you want to, or it adds this one for you, right? So it's completely under your control. So it's A, and diameter is 10. Now I don't see any symbol here for diameter, right? I don't see any of that. But the good thing is it added it itself. Why? Because I'm referring to that circle. And again, if you want, you can get rid of that circle. Oh, sorry. You can get rid of that circle. Let's see. And here, let this command take over like that. Okay, so you see it recognizes that's a circle, and it added, when you called it A1, it says phi of 10. Okay, so this is how you add a datum target in SolidWorks. Okay, what else do we have? Another thing we have is called the common datum feature. This is when you basically have, like here, let's say 2 cylindrical surfaces, and they both sit on bearings, right? Let's say, and they share in the same axis. So instead of using, for example, this partial datum A as only datum, or using partial datum B as your only datum, right? You're using both of them. You say A dash B. That means they are both a common feature for here for this total run out. So when I want to check the total run out, when I want to check whether this guy wobbles or not, I have to make sure A and B are both basically sitting on my here the V surfaces, right? The V supports, the V blocks you might call. So that is called the common feature. So if you say A dash B, that means a common thing. Now SolidWorks, pay attention that in SolidWorks, when you add datums, it shows it as a common thing. So let me show you here. So let's say here I make this guy datum B, right? Or you know what, let me add something here. So let's say because we want to make sure these are good surfaces, right? So here I click on this, and then let's just bring it up here. Then say this has to be has flatness with maybe 0.05 or something. Okay, and then I need here, and you can merge these two together if you want. And here, let's just add another one here and say this has to be perpendicular with a tolerance zone of 0.08 or 0.008, right? 8000 with datum A. Okay, and then call this one datum B, huh? So here, look, I bring B and I merge it to this one, right? And I call it B. There we go. So that's my datum B, which is perpendicular to A. Now, if I want to do like a position or something with respect to A and B, right? Then look here. So if I click here and maybe click at the center and bring it out and use a position, right? And phi of, let's say, 0.04. And you say add datum, and I do add datum A and then B. Look what it does. So if you look, sorry, I need to use capital B. If you see, it shows it like a common feature. Okay, and it's kind of is, because really when you want to inspect the position of that center, you have to make sure that A and B are in contact with your inspection table and the wedges, but it's not exactly the same as here, which is like A and B, they share a common axis, so we use them as a common thing. Okay, because in GD&T, if you look, you basically, when you have A and B or stuff like that, let me show you an example that I'm gonna make soon for you. So you put these walls between A, B, and C, and you don't use a dash, okay? Now in SolidWorks, as I showed you, when you click here, right, and if I double click there on the datum part, you see it is adding a basically a dash for you instead of adding a what, adding a line. So just pay attention that that's a little bit different in terms of common feature. That's not exactly what we just said. Okay, the last thing I want to talk about is called a common feature, which you can see it with this shape and a CF. So if you see that CF somewhere in drawing, it's a common feature. What does it mean? So look here, I put a diameter and then a limit form of 22.1, 22.2 on this surface, but I say this is a common feature. That, what does it mean? It means that applies also to this one as well. So both of them are within those tolerance limits. Okay, or if you do a model-based drawing, you again do it like that. So the CF thing is something like when we had the tolerance, the dimension tolerance lectures, if you remember, we had this TYP, remember, typical. So we said that, hey, this diameter is typical, or this offset is typical. So that's a similar thing. In GD&T, we use a CF and say, hey, this is a common feature. Now in SolidWorks, if you want to do that, so let's say here I have this diameter, I put on this object, and then for tolerance, I use the limit form plus minus 100,000, right? So here you want to add that CF to it, right? So you saw that with these guys, I had the CF with this geometric symbol thing. If you remember, right, let me show you. When you double clicked on this datum part, you see here you have the CF. But what about the dimensions? If you want to add it to this dimension here, not the geometry, the feature control frame, is there any way you can do it? Yes. So here you have this box called tolerance modifier, and you have to check this to make it active. And then, since it's for both of them, not for one of the limits, you click under general and you click here, and it has some symbols, but as you can see here, you don't see CG. There is CC and CA and CV, but not CG. So you click here on more symbols, and then here under more symbols, you go to modifying symbols, and under modifying symbols, you see there is CF. So you can add that CF right there, and boom, you got it. Okay, so this is how you add it to a specific dimension here. So hopefully this was useful to you and you learned how to add these specific things, which are partial datum, datum target, common datum feature, and continuous feature. And I'll see you in my next lecture. Thank you.